Good morning. Today we are going to look at lesson 10.4, exploring nonlinear relationships. As always, let's get started with a few review problems. So let's see what happens when we use these values. Find the values of y when x equals -4, 1, and 7. So this would be similar to the previous problems we've done in this unit where we are plugging in values of x. I'm going to use a table to keep my work organized, but this time the values that they're giving me are -4, 1, and 7. I'm not picking the values. I'm going to put my rule in the middle, and then y goes on the other side. So when I substitute in -4, I'm going to get 3 times -4 minus 2. That would give me -12 minus 2, and -12 minus 2 would give me -14. All right, next I have 1, so I'm going to do 3 times 1 minus 2. Well, 3 times 1 is 3, and then minus 2 is 1. Finally, we have 7, so we can say 3 times 7 minus 2. 3 times 7 is 21, minus 2 is 19. So we would say, okay, when x equals -4, y equals -14. When x equals 1, we would say y equals 1. And when x equals 7, y equals 19. So that's for the first equation. For the second one, I'm going to make my work over here so I've got more space. Got y equals 4 minus x. So I've got -4, 1, and 7. So I'm going to have, actually I want to write the y. I want to write 4 minus, and I want to be careful here, that minus that was given to me does not account for this negative in the 4. So 4 minus -4, that would make it 4 plus 4, which is 8. 4 minus 1, which is 3. And 4 minus 7, which is -3. So just pay attention to your signs and you should be good. All right. Today we are looking specifically at nonlinear equations, and a nonlinear equation is an equation with a graph that is not a straight line. Everything we've been doing up till now has made straight lines. You know, they've looked like this, or like this, or like this, or like this. They've made straight lines. But we're going to look at two specific nonlinear equations today. The first one is a parabola. And a parabola is an equation with x squared in it, and the graph makes a curve. It's either going to look like this, like a U, or it's going to look like this. I kind of call that one the mountain, or you can just call it an upside down U, but that is what a parabola looks like. It makes a curve. And then there's a absolute value, which is an equation with the absolute value bars around the x, and the graph is going to make a V shape. It can open either like this, or it can open upside down, just depending on if it's positive or negative. So these are the two types of graphs, but they could open in different directions. So 4 graphs that we're going to look at today. And we're going to do that by making a table. So graph the equation y equals -x squared plus 1. In this, it is very important that we do use the values that I'm about to give you. -2, -1, 0, 1, and 2. We definitely need to use these values because if we don't, we're going to get values that are way off the graph. And just to kind of show that, I am going to include -3 and 3 down here. We'll do those as like extra problems, and I'll show you why using values that are outside of these 5 right here can cause problems for us. So I'm going to be careful. This negative right here is outside of the x squared. So I'm going to write negative and then -2 squared and then plus 1. So all I did was take out this x right here and replace it with -2. The negative stayed and the squared stayed and the plus 1 stayed. So be very, very careful when doing these. So if I do that off here to the side, I would have negative, and -2 squared is -2 times -2, which is +4. And then plus 1, so this would give me -4 plus 1. Guys, you're going to have to be very, very careful when you're dealing with negatives here. It's very easy to make a mistake. So we're going to get -2 and -3. All right, so for -1, we'd have -1 squared plus 1. Now I'm going to show my work over here. Negative 1 squared is positive 1 because it'd be negative 1 times negative 1 and then plus 1. So this would give me negative 1 plus 1, which is 0. So I'm going to have the point negative 1, 0. And then I've got negative 0. Oh, I don't want to use that color on here. Let's change it here. Negative 0 squared plus 1. Well, 0 squared is just 0, so I'm going to have negative 0, which that sounds silly at first, but I'm just going to go ahead and show it. That's just 0. And so 0 plus 1 is 1. And I'm going to have the point 0, 1. All right, plugging in 1. I'm going to have negative and then 1 squared plus 1. Well, 1 squared is 1, so I'm going to have negative 1 plus 1. And now we're back to, it looks the same as when we plugged in negative 1 after we squared that, the negative 1 and the positive 1. Oops. And so I'm going to get 0 again. That's a little odd. So we're going to get 1, 0. And then for 2, we're going to have negative 2 squared plus 1. Well, that would give me negative, and then in parentheses 4. I'm keeping this 4 in parentheses to remind myself that that negative is outside. It's not being multiplied until the very end. We have to do exponents first by the order of operations, PEMDAS. So this would give me negative 3. Oh, I got the same thing as I did up here. That's interesting. So let's see what happens when we graph these. All right, so I've got 2, negative 3, so I'm going to go 2 and then down 3. I have, let's see, that one was this. So for this one here, I've got 1, 0, which is going to go right here. Then I have 0, 1, which is going to go here. And then I have negative 1, 0. And then I have negative 2, negative 3. So here are my points. And so it actually makes sense that I have points that are repeating, because when I connect my dots, it makes that upside down shape, that upside down U shape. So if I were to plug in negative 3, I would get negative 3 squared plus 1. Well, that would give me negative 9 plus 1, which is negative 8. So that's going to be here. And then I should get the same number for 3. And so in this case, I would be able to graph the parabola on with the x equals 3 value. However, it's going to get very close and usually go off the graph. So sticking with these first 5 values is what you need to do for this. All right, so try this one in your notes and then come back and check your work. Okay, so hopefully you were able to try this problem on your own and get something that looks kind of similar. A very common mistake that people make is they forget, where is it? There we go. They forget this. So remember, we have to do anything in parentheses first and then take care of our exponents. Well, we don't have anything in parentheses, but when I, or we don't have anything to simplify in parentheses, but when I substitute in negative 2, a lot of people will do 3 times negative 2 is negative 6, and then they square that and get 36. But because of order of operations, we have to do the exponents first. So you can see here what I did was I actually squared negative 2 first and then multiplied it by 3. So when I did that, I got 12. And so I graphed the point negative 2, 12. And even by using some of these smaller numbers like negative 2 and positive 2, I still am ending up with values that are off the graph. And that's okay. I'm going to do my best. Here I ended up with negative 1, 3, 0, 0, and 1, 3. I'm moving through these parts pretty quickly because hopefully we are feeling pretty confident about substituting in points and graphing them, but I want to talk about connecting them. So I see that they're changing at different rates. It's not a straight line, but we need to make sure that we're very clearly showing that it is a curve. And if you don't draw a perfect parabola, that's fine, but I can tell a difference between if you're connecting them all with straight lines or if you're just drawing a V versus if you are doing a curve. So take your time to make sure that you make it look nice. All right, one more for you to try. Try this on your own and then come back. All right, here's the work for the third example. You can see that I did have an x squared, so it made it a U shape. And because it had a negative here, it was opening down. When there's no negative, when it's a positive, it opens up. Negative, it opens down. If you didn't get one of those, pause the video and just see if you can figure out what your mistake was. All right, so let's look at some absolute values now. We're still going to use the same values of -2, -1, 0, 1, and 2. But this time, I'm substituting them into the absolute value bar. Voila, just like this. So when I'm looking at this first value here, I'm going to say, okay, I've got absolute value of -2, and absolute value is measuring distance. So how far away is -2 from 0? It's 2 away. So I've got 2 plus 4, which gives me 6. And then I'm going to have the point -2, 6. So let me graph that, -2, 6. All right. Next, I have -1 plus 4. Well, the distance of -1 from 0 is 1, and then plus 4 would give me 5. There we go. Next, I have, well, the absolute value of 0 is just 0. It's 0 away from 0. But then I have to add 4, and I'd get 4. And notice here, this is changing like a straight line in the sense that it's changing by the same amount each time. So we've got 0, 4. Absolute value of 1 is 1. But then it's going to start working its way back up. So this would give me 2 plus 4, which is 6. And that would give me 2, 6. So I didn't graph my other points. I'm just going to put them on here real fast in the same color. And so now what should happen is these should make straight lines going opposite directions. Just like that, and it makes a V. And that is what an absolute value looks like. There's a positive in front of the absolute value, so it opens up. Try this one in your notes. All right, so you should have gotten something that looks like this. And you can see I've got these points, and when I connect them with the line, it should look something like this, more or less. That one was a little more bumpy, but I'm doing this on a computer and it's a little harder. But it should make relatively straight lines, hopefully looking better than what I did. But that's how we would graph it. All right, you've got one more in your notes. Go ahead and try that and then come back. Okay, so you should end up with something that looks like this. Again, remember that when we're taking the absolute value, this is my work over here. I'm showing, I didn't leave myself enough work in the table. So this is my work. I'm saying, okay, this is what I get when I substitute in -2. But when I actually do the work, I'm getting, okay, the absolute value of -2 is 2. So 3 times 2 is 6. And then I think it's an important step to write the ordered pair. And so it's something that you need to do as well. It's good practice for us to remind ourselves that this is what we're actually graphing. We're not just graphing 6. We're also graphing the -2. The -2 is part of this. It's the input. So connecting my dots, I'm going to get that. And, ooh, that got a little bumpy, but you get it. That's the general idea. Again, I'm going to look for, do you know what shape it should make? So make sure you take your time and do your best to make it look a little bit better than what I did right there.